Okay, so again, you have a piece of paper in front of you, and this will actually end up in our binder. It's going to be one of like our reference sheets that we're going to refer back to throughout the year. So we're going to start talking about the order of operations today, which I think you guys have all heard those words before, right? And the order of operations are the order of operations. You don't add to it the older you get. It's just the problems get a little bit harder. The problems get longer the older you get, but the order of operations don't change. So who can tell me, in math, there are really only 4 mathematical operations. No matter how old you are, there's only 4 mathematical operations. Who thinks they can give me one of them? Audrey. That's 2. Multiplication and division are 2 of the 4 operations. Dylan. Subtraction is 1. And Easton T? We already said division. Multiplication, division, and addition and subtraction. Add, subtract, multiply, divide. Those are the only 4 mathematical operations that exist. Now, there are other things like exponents, okay? But exponents are having us do what kind of mathematical operation? Multiplication. It's just a fancy multiplication problem, okay? Fractions are just telling us to do what? Division, okay? So there's only 4 mathematical operations. We can do lots of fancy stuff, and the older you get, the fancier the stuff gets, but ultimately you're only doing add, subtract, multiply, divide, okay? So anytime you have a math problem with more than one operation in it, meaning it has addition and multiplication, or division and subtraction, or exponents and division, you have to follow the order of operations to be able to get to the correct answer, okay? Our brain wants us to work all math problems from the left side to the right side. Why do you think our brain wants us to work problems from left to right all the time rather than follow this order of operations? Emma? Yeah, because we read from left to right, okay? So our brain wants to work from left to right. And sometimes we do have to work from left to right, but only if we're on those last 2 steps. So let's go through this order of operations and kind of talk about them. Okay, and it's also a mnemonic device. I always say PEMDAS. Where do you think I get PEMDAS from? Waylon? Yeah, the first letter of each of those words. Parentheses, exponents, multiplication and division, addition and subtraction. And a phrase that a lot of people use is, please excuse my dear Aunt Sally, okay? But I use PEMDAS because I want you to kind of picture the way that it's written, because MD are grouped together and AS are grouped together, okay? So we're going to talk about why now. So anytime we have an order of operations problem, okay, anytime you have a problem with lots of different math symbols in it, add, subtract, multiply, divide, you look for parentheses first, okay? We know what parentheses are, but it really includes all grouping symbols, okay? The most common is the parentheses, okay, which we're familiar with. These are called brackets, like the box parentheses. Oops, didn't mean to do that. The box parentheses. And these fancy parentheses are called braces, okay? Those are all considered grouping symbols, and in an order of operation problems, we have to do that first, okay? We always look for that first. If there's more than one set in a problem, we go to the innermost set. That's what it says here, innermost first if there is more than one set. What do you think innermost means? It's kind of a weird word. Emma? Not the one that has the most inside of it. Good guess. Innermost. I want you to go ahead and flip this over to the back so I can explain what innermost means. It's almost easier to see with an example. Look at this last example. There's lots of grouping symbols. Look at the right side of the problem. Do you see how there's kind of 2 sets of grouping symbols and one of them's inside of the other one? Dylan, which problem there do you think is the innermost problem? 3 times 3, because it's kind of the set of parentheses inside of the other parentheses, okay? And again, this is not an introductory level 5th grade order of operation problems. I'm starting you with the hard ones so that when you see them, you're like, oh, these aren't bad at all. Okay, I kind of do the hard ones with you so you can see kind of where we're going, okay? But that 3 times 3 is the innermost parenthesis in that problem. Okay, let's flip back to the front. So we always do grouping symbols first. In sign language, okay, this is how I remember this. I went to school with a student who was deaf, so he had a teacher with him all day long. The teacher would be standing up here teaching, and he had a teacher that kind of stood next to him and would sign all day long what the teacher was saying. So she did this a lot with her hands. She put her hands kind of around her eyes and did this. What does that kind of look like? Parentheses, okay, but yeah, that means like pay attention, focus. So all day long she'd say, focus, focus, Tony, focus. So I learned that sign pretty easily. So, but when we do order of operations, I think of those parentheses. It's like, hey, focus right here. Those parentheses are kind of telling you where to focus in the problem first. Okay, once we get rid of all the grouping symbols, then we move on to exponents. We know what exponents are. We know what exponents look like. Okay, but we have to evaluate the powers, meaning solve them. So if we had 3 squared in a problem, what math problem would I do, Sophia? If I had 3 squared in a problem, I would do 3 times 3. Okay? Once we do all of the exponents and there are no exponents left in our problem, we move on to multiplication and division. Okay? I want to point out it is not multiply in one step and then divide in one step. Multiply and divide happen in the same step. Sometimes we do our multiplication and then division. Sometimes we do division and then multiplication. How do I decide which problem to do first if I have both multiplication and division? Madison? Yeah, this is one where if there is a multiplication sign and a division sign, we read it like a book. We start on the left. If the farthest left problem is a division problem, then that's what we do first. If it's a multiplication problem, then that's what we do first. Okay? So MD is grouped together. Sometimes it could be divide and multiply. Sometimes it could be multiply and divide. Sometimes it could just be multiply. Sometimes it could just be divide. It just depends what is in the problem. And then we move on to addition and subtraction. It's the same thing from left to right. If there's a subtraction problem on the left, we would do subtraction first. If addition is on the left, we would do addition first. Sometimes there's just one or the other. Sometimes there's no addition or subtraction. Okay, it's just that's our last step if it is there. So really to practice these, we just have to practice, okay? But I'm going to tell you now, if you mess up, it's because you're going to want to work from left to right all the time, and that doesn't work. Okay, flip your paper over to the back. With these, I'm pretty picky at the beginning because I know where you're going to mess up before you mess up. Okay, you're going to lump too many things together that build on each other, and you'll be off from that point. So when we're working, you're only allowed to do one math problem in each step. Okay, and we're going to underline the math problem that we're doing so that we don't duplicate any numbers or use them a second time, even though we've already used them. When we're working, till we get better at these, each time you work a problem, we're going to make ourselves a little checklist out to the side. So come out here in the margin, P-E-M-D-A-S. Write our little mnemonic device, because that's our checklist. We have to go through that entire list to be able to get this answer correct. What does the P stand for? Cameron, what does the P stand for? Parentheses or grouping symbols. I'm always going to add that because it's parentheses or grouping symbols. Drake, do I have any?
Yeah.
Okay, what's in parentheses?
3 times 5.
3 times 5. So everybody underline 3 times 5. That's the one problem we're going to solve in this step. Caleb, what's 3 times 5? 15. So I write my answer underneath. Everything else drops straight down. We don't flip anything around. We just drop it straight down. When we are done with order of operation problems, it should look like an upside down triangle because each time the problem gets a little bit shorter till we have a single answer at the end. Okay, do we have any other parentheses? Nope, so let's mark it off. We're done with our parentheses and grouping symbols. Audrey, what am I looking for next? Exponents. Do I have any? Yeah. Okay, if I don't have any, we just mark it off and move on to the next step. What do I have that's exponents?
4 to the 2nd power.
Okay, let's underline 4 to the 2nd power. That's the math problem we're going to do this time. Let's, for our example, go ahead and write out to the side what that's telling us to do. Because what do you think a common wrong answer is to 4 squared? Emma, sorry. 8, but what is 4 times 4? 16. So 4 squared is 16. We drop everything else down. Go back to my checklist. Do I have any more exponents? Nope. Sometimes you'll have to do multiply and divide 3 or 4 times before you can mark it off. You keep going till you are done with it. Okay, we are done with exponents. Next, multiply and divide from left to right. Michaela, do I have any multiplication or division?
You have multiplication.
Okay, and I only have one problem, so it's pretty easy to guess which one we do. What are we going to do?
2 times 3.
Okay, let's underline 2 times 3. What is 2 times 3? 6. So I'm going to write 6. I'm going to copy everything else down exactly how it looks. I'm going to mark off multiply and divide because that's it. I'm down to just subtraction and addition. Now, my rule is add and subtract from left to right. It's not add and then subtract. So, Kylie, what am I going to do next?
16 minus 6.
Yes, because that's the problem on the left. Okay, addition and subtraction we do at the same time. We go from left to right. So what is 16 minus 6? 10 plus 15. It's just 25. Okay, and you don't have to show this, but if you look, your work should always kind of look like an upside down triangle. Because we keep going till we have it down to a single number. Sometimes it's a 2-digit number, sometimes it's a 3-digit number. Now, if we would have worked this one wrong, I'm just going to show you, you would not get the same answer if you work it wrong. Here, a lot of people want to do, don't change your answer because this is wrong, want to do that first because they say Aunt Sally. Aunt comes before Sally. Addition comes before subtraction, which is incorrect. What is 6 plus 15? 21. What's 16 minus 21? -5, okay? We don't do negatives till 6th grade. And really, once you learn integers and negatives, that's actually -6 plus 15, and you can do it, but we're not there yet. Okay? Let's move over to the right. Again, for each one tonight, I want us to write our little mnemonic device out to the side. Please excuse my dear Aunt Sally. Because the more you write it, the more likely you are to what? Remember it. Remember it. P. Grayson, what does that P stand for? You can flip it over to the front if you need to.
Parentheses.
Parentheses and grouping symbols. Mila, do I have any?
Yeah.
Yes, what am I going to underline?
2 plus
Okay, what is 2 plus 3, Mila?
5.
5. So I do that one math problem and I copy everything else down exactly how I see it. Do I have any other parentheses? Nope, so let's mark it off. Exponents, Brennan.
You don't have any.
So let's go ahead and mark that off. Don't have any. What do I do next then, Brennan?
Then you go to the MD, which is multiplication and division.
Multiplication and division. Can you add to that from, how do we read?
From left to right.
Yeah, multiplication and division from left to right. So in this problem, if I look, I'm just focusing on multiplication and division in this step. So I don't underline anything yet, but I have this problem and I have that problem. Do you guys see the multiplication and division problem in the same line? Which one do I do first and why? Callie?
9
Good job. 9 times 2 because it's on the left side. I'm going to get rid of my lines. We're going to do 9 times 2. What is 9 times 2, Callie?
18.
18. Drop everything else down. And again, you'll get to where you can skip steps. We're just not ready for that yet. Noelle, what am I going to do next?
You're going to divide 12 times 3.
12 divided by 3.
Divided
What is 12 divided by 3?
4.
4. So I'm going to put that that's 4. Okay, do I have any more multiplication or division? Nope, so let's mark it off. Now I'm down to addition and subtraction. Arabella, what am I going to do first?
5 plus 18.
Why am I going to do 5 plus 18 first? Because if I'm doing addition and subtraction, I start on the left and work my way across. 5 plus 18, Zach? 23, good job. Minus 4. Anybody? Just say it. 19. Okay, we got it down to a single answer. And does our work look like an upside down triangle? Yeah. Now, one thing that gets kind of confusing is students, once they get working, they don't know, when do I get rid of the parentheses? Have you guys noticed, when do we make the parentheses kind of disappear? Audrey?
After we get to that problem and write it again.
What do you mean when we write it again?
I don't know what I meant by that. Like when, like with the 2 plus 3, we didn't add 2 plus 3 equals 5. We just wrote down 5.
Okay, so when we get what's in parentheses to a single number, okay, when you get it down to one single answer, completely simplified, that's when we get rid of the parentheses. Okay, one thing I'm going to make a side note on, and you don't have to write this anywhere, I just want to point it out. If you have this problem, and again, you don't have to write it, I think just watching will be good enough. For this, parentheses mean do this first. Put your attention right here. Why, even when I put my focus right there inside of these parentheses, is this one kind of confusing? Drake?
There's 3 numbers and 2 problems.
Yeah, there's 3 numbers and 2 operations. What do you think I have to follow when I'm inside of those parentheses, Easton? Yeah, I have to follow the order of operations. So I have to do the division first because division comes before subtraction, the other operation up there. So in this one, I would do 8 divided by 2 is 4, but I still keep it in parentheses right now. Why am I still keeping that in parentheses, Arabella? Yeah, I don't have it down to a single number. So then I would have 24 minus 4. Oops, I forgot to copy that down. That would be 20 and then plus 4. So now I would get rid of them because I got those parentheses down to a single number. And then I just add that 4 back on. Okay, and again, is that an entry-level 5th grade order of operation problems? No. Okay, I'm giving you the hard ones just to show you kind of where we're going with these. I'm giving you the hard examples so that when you're doing the easier ones, they're not so terrible. Okay, let's look at this next one. Let's write our mnemonic device out to the side. Colby, what am I going to do first? What does the P stand for? Because I always go through my checklist. Parentheses, do I have any? Okay, so we're going to underline the 3 plus 8. Ty, what's 3 plus 8? 11. So under my underline, I'm going to write 11 and then copy everything else down. And if it helps, after you write a problem, look at what operations you have. We have multiplication, addition, and division. So I'm done with my parentheses. I'm done with my exponents. I'm to multiply and divide. Waylon, what am I going to underline?
6 times 11.
Okay, why am I doing 6 times 11 and not 16 divided by 4?
Because 6 times 11 is on the left.
It's on the left. Good job. We go left to right. So that is 66 plus 16 divided by 4. Now, something I want to point out, we had to save order of operations till after we did multiplication and division. Because sometimes you may have to go out to the side and do a longer multiplication problem. Do we know how to do 26 times 7? Yes, we don't have it up here in our brain to do mentally, but we can go out to the side and do some scratch work, whatever I said, 24 times 7 or 26 times 7. Sometimes we may have to do a long division problem. Okay, those aren't our favorite ones, but we are capable of doing it. Okay, what am I going to underline next? Mila?
16 divided by 4.
Good job. 16 divided by 4 is what?
And 4.
4. Okay, so now I'm down just to addition, so I'm going to mark off my multiply and divide. Add and subtract last. 66 plus 4. Caleb? 70. Okay, and again, my work should look like an upside down triangle. Doesn't have to be perfect, but it should be close. Okay, now the hardest one on the page. I tried to throw in anything that you could potentially see that confuses you throughout order of operations. So I don't have to delete that. I'm going to write my PEMDAS right here. You guys can do it out to the side on the right. I'm going to write mine right here. Okay, lots going on in this one. Parentheses, there's lots of them. Noel?
You should start with the 10 minus 8.
Okay, we can start with that one because it's on the left and it's kind of out there by itself. 10 minus 8 is what? 2. What do you think I do with that 3? Emma?
You put it as the exponent of 2.
Yeah, now that becomes the exponent of this 2. So it just kind of gets shoved right there. I copy down everything else. When you draw these brackets, usually you just do like boxes, like open boxes. 6 plus parentheses, 3 times 3, close parentheses, close brackets. We still have parentheses, so can I mark it off yet? Nope, and this is one that we have to look at. The front says you go to the innermost parentheses first. So Kylie, which ones are the innermost? 3 times 3, the ones that are on the inside. Innermost just means the inside. So I'm going to underline 3 times 3, copy everything else down, open my brackets, 6 plus, what is 3 times 3? 9. Can I get rid of my parentheses and leave my brackets? Yes, because 3 times 3, I got it down to a single number. Now I have my brackets. Emma?
Would you use like different types of parentheses? Like for the outer one, it uses brackets, but the inner one uses.
Not always. They could have done multiple sets of just regular old parentheses. Usually they try and do different ones just so you can tell which ones go together. But they could have also given us this problem with these as just another set. And you can just tell because it's like there's 2 of them back there at the back, kind of closing 2 different sets. So they do try and give us different ones just to keep it organized, but they don't have to. Okay, what am I going to do next? Callie?
You're going to do your exponent.
Are we done with all the parentheses and grouping symbols? Nope, so we have to keep on it till we're done with it. So let's still have grouping symbols. What's 6 plus 9? 15. Yep, and that's why this one's a hard one. Because you got to keep going with that same thing till they're all gone. So now we can finally mark off our grouping symbols. All of that work, and all we've got marked off is the P. Milo, what's next?
You have to do 2 times 3.
Hold on, we have to do the exponents. I agree with exponents. I disagree with 2 times 3.
You have to put 2 3 times.
2 3 times. There we go. So out to the side, we're going to write this 2 times 2 times 2. Sometimes we have to do scratch work out to the side. Easton G, what's 2 times 2?
4.
What's 4 times 2? 8. So 2 cubed is just 8 times 15. Most of us don't know our multiples of 8 up to 15, but what do we know? Kylie?
15 times 2 is 30.
Okay, 15 times 2 is 30. Do we know how to do algorithm? Do we know how to do lattice? Do we know a million different ways to multiply 8 times 15? Yeah, so this is one where we may have to go out to the side and do some scratch work. Okay, it's not going to be our favorite problem to have to go out to the side and do scratch work, but it doesn't mean we can't do it. We just don't like to do it. So that ugly problem simplifies all the way down to 120. Now, these are confusing problems, and there's a million different places you can mess up. Okay? Million different places you can mess up. So, on your homework tonight, I'm going to just show you this before I pass it out, because usually once I pass it out, you guys quit listening. And you're going to do them all on loose leaf anyway. Okay? There's problems, a worksheet that has 10 problems on it. Okay? What you're going to do for homework is you're going to do the evens. How many problems is that? 5. You're going to do the evens. You're going to do 2, 4, 6, 8, and 10. And then you're going to choose 2 odds. Okay? If I want you to do your evens first. Okay? And just maybe write choose 2 odds. If you're like, hey, I'm getting these right, these are easy, choose some hard ones. Okay, if you're like, hey, I'm struggling, choose some of the beginning ones. Okay, who is this for? It's for you to challenge yourself into practice. This is brand new, so do I expect you to be perfect? No. What do I expect? You to try your best. And because this is new and there's a million different ways to mess up, on the back of your worksheet, I'm giving you the answers. They don't look quite like this, but the answers are on the back of your worksheet. Why do you think I would do that? Michaela?
Just in case you get confused.
I want you to check your answers. If you check number 1 or number 2 and you get 28, and you look and you're like, oh, the answer is 21, I want you to flip it back over and see if you can find your mistake. If you can't, what should you do? Ask for help. Okay, but a lot of times you can usually find it. If you know where your end point, you can usually kind of figure out where you need to go and where you messed up. Okay, I have one other thing I want to pass out before the worksheet. It's the weekly worksheet. Let me pause. Okay, so on the weekly worksheet, there are 2 skills this week. It says E4, multiply whole numbers by powers of 10. So everybody pull out the weekly worksheet that I just passed out, the IXL page. Skill E4 says multiply whole numbers by power of 10. I want you to go down in the workspace and write this problem. These are the types of problems that will be on E4. Grayson, we're writing on this. Okay? Notice there's a note there that says there should be work for all of the E4 problems. Did I skip you?
Yeah. No, I need it for Lori.
Oh, I'll get a whole stack for him in just a sec. Okay? Well, what work can I show for these? These are ones we're still missing. That's why I'm going to backtrack and have us try some more. Callie?
10 times 10 times 10.
Yeah, that 10. And really, this is an order of operation problem. You guys just didn't know it was an order of operation problem, because we're going to do the exponents first. Okay, but that's 10 times 10 times 10 times 10. And I can go ahead and copy down my 4 times. Now I just have a multiplication problem. Emma, what's 4 times 1 times 1 times 1 times 1? 4. And then how many zeros do I need? 4. 1, 2, 3, 4. So do those problems take a whole lot of time to show work? No. And usually it takes about 12 problems if you get them all correct to get to a 75. Okay, so I should see 12 or 13 of those written down. F5 says it's on divisibility rules, and it says use your binder. What do you have in your binder that can be beneficial here, Waylon? What's it say at the top? Divisibility rules. The plastic sheet inside of your binder that has your multiplication chart. The back side of it, I want everybody to get their binder out and find it. The back side of it has your divisibility rules. I know you talk about those in 4th grade. We've talked about them here, but the best way to learn them is just to practice them, okay? That skill is just yes or no. It'll give you a number and it'll say is 5,293. I'm going to write that. You don't have to write it. 5,293 divisible by 3, yes or no? How do I decide if a number is divisible by 3? Arabella, what's my rule say? The sum of the digits is divisible by 3. What does that mean? The sum of the digits is divisible by 3. Emma?
Does it mean that you add the numbers?
Yeah, you add the digits. So what's 5 plus 2? 7 plus 9? 7 plus 9 is 16, plus 3 is 19. Is 19 divisible by 3? No, so that means 5,293 is not divisible by 3. Okay, so when you're doing skill F5, I highly, highly, highly suggest you have your divisibility rules next to you. Double check them before you mark yes or no. Okay, there are some easier ones, like if it ends in a 5 or a 0, it's divisible by 5. 3 and 9 and 6 are the ones that really we need some practice on, okay? Okay, I'm going to pass out tonight's worksheet. You can get started on it. Where are you doing all of your work? On the loose leaf. I'm also going to give you a plastic sleeve. I want you to put your order of operations page in your plastic sleeve, and then it's going to become a reference sheet for the rest of the year, okay? So I'm going to pass that out, and you guys can get going on your homework.